All right, today's chapter 2 started. We're actually going to start looking at some numbers because let's face it, there wasn't a whole lot of any calculating going on in chapter 1. It was basically definitions and what kind of level of measurement we're talking about. And so now we're going to start organizing it. As you can see here, their graphs is what it's talking about. So we're going to just kind of start organizing it. Once that we do a couple by hand, then we'll let some software take care of the rest of that for us. So a frequency distribution. When you hear the word frequency, what comes to mind?
Radio.
Okay, a radio. It does actually mean the same thing in radio. Because radio waves, how frequently the radio wave repeats is actually the frequency. It's how often it repeats. As when we talked about sine and cosine, for those of you that had that, how often it repeats is the frequency. But now it's a distribution. So it's basically going to be a table normally, or a chart if you want to use that word, that shows classes, or they're called intervals sometimes, of the data entries with a count of the number of entries in each class. So kind of like tallies, basically. How many are in each interval or how many are in each class. Again, these definitions kind of have to be general because you can use them for various things, and so they keep them, they don't get too specific, basically. And I think that'll make sense once you see what we're going to do. It sounds kind of hard when you read it that way, but it really isn't. So then what would the word just frequency itself mean based on this? Yeah, how often something happens, pretty much, is really what it boils down to. Or in this case, the number of data entries in that class is kind of the frequency. So how often does a data entry end up in that class? So how often did it happen? Okay, so that's exactly what it means. In Algebra 2 and in Advanced Math, you saw the sigma. It was when we were doing sequence and series. It was more when you were doing series. Sigma stands for? Nope. The Greek letter that stands for sum. Not S-O-M-E, S-U-M. As in add them up. Series were the ones that you were adding up the terms. That's why you saw sigma in there. What you're going to find as we go through this chapter is there is a lot of just letters that stand for things, and you're supposed to know that. And we'll go over them to make sure that you do. So when you see sigma, you should know that means add them up. Okay. So here's an example. There's the number of minutes 50 internet subscribers spent online during the most recent session. Construct a frequency distribution that has 7 classes or intervals. When you see the word class, you can kind of think of intervals. So basically, it's telling me how many it would like. Okay. Kind of those of you that had calculus already know that we were told sometimes to divide things up into certain intervals in there as well. So before we do that, though, I see a whole bunch of numbers right there. We have to figure out how big is each class going to be, and that's where class size comes in. How big should I make it? Should I just make this one class and say, oh, let's just make it 0 to 100, and they all fit in there? Well, that's not a very good chart or a very good table. So what you do to find class size is you got to look through your data. Now, this is not ordered data, so it gets a little more complicated. Look for the biggest and look for the smallest, is what you're going to want to do to help you find how big each class should be. Yeah, I believe 7 is the smallest, correct, right there. And is 88 the biggest? Yep. And what you do is you find out, well, what's the range there? What's the difference between those? So you go ahead and you subtract. So 88 minus 7. It's probably best to take biggest minus smallest. Negative numbers might confuse you. And you find out what that number is. It's fairly straightforward that is 81, right? I'm not going to make each class 81 units long, because then we could just go from 7 to 88 and they'd all fit in there. What you're going to do then is take that number and divide by however many classes you have been suggested to get. And according to this one, I'm supposed to get 7 of them. Now these numbers are not always going to end up nice, and I chose this one because it's 81 divided by 7. Right? That does not divide evenly. And so you pretty much do the best you can. Okay? And so first we'll just approximate that, and then we'll decide, well, which way should we kind of round that? Okay? So 81, or yeah, so basically it's 81 divided by 7, right? And we get approximately what, 11.47. Excellent. You could do it that way, and I'll explain that in a second, but about 11.6, give or take, right, if you round? Well, I don't know about you, but I don't want to sit here and go from 7 to 18, you know, do it that way. I don't want to sit there and do decimals. So let's just go ahead, let's just round this. We'll say we'll use 12, right? Now, the 4/7 would have also rounded you to 12, so it still would have worked, all right, because 4/7 is more than half, right? So basically what we're going to do is we're going to make each interval that we're going to use, we're just going to say 12. So you take your smallest, and we say, okay, start at 7. And all the way, well, if each one's going to be 12 wide, you could look at it that way. I'm going to go from 7 to... Now, why 7 to 18? Why is it not 7 to 19? Yeah, because 7's included. Remember when you subtract? Like if I were to do 18 minus 7, when you subtract that, you're throwing 7 out, right? Where really I want 7 to be in there. I think we had this discussion when we were doing the 100th anniversary. Everybody was disputing whether it was actually the 100th anniversary, because when you subtract, you always throw out that last one, when actually it should be included. So be careful. Or what some people do is if your class size is 12, just add 1 less than that. It makes it easier. Just add 11 instead. Does that make sense? So then we're going to go 7 to 18. Now look at these numbers. Do we have like 18 and a half or, you know, anything like that in here? No, so I don't have to say like 18.1 to the next one, right? I can just jump and just go to 19, right? I don't have to sit there monkeying around with those halves and all that stuff. Now, if you ever get those, well, then you got to be a little bit more clever of how you're going to divide that thing up. Okay, so now be careful. If you add 12 to that, you get 2. Or add 11 might be the better way, like I said, do it. You get 2, 30, okay. Because they are 12 wide, because you got 19, 20, and so forth and so on. And then just kind of finish that up, you know, 31 to 42. And how far do we got to go? We only have to go until we take care of our last number, which is 88, right? So now are we going to hit 88 exact? What do you think? No, because we rounded that thing, right? We rounded that class size. So we're not going to hit 88 perfect, but it'll at least be in there. And that's why often you kind of want to round up, because then you make sure that you kind of fit that in there. So 43 to 54, 55 to 66, 67 to 78, 79 to 90. Right? Then probably the easiest thing to do is just kind of go through your numbers and find where they fit. If I were you, I would probably kind of give myself some lines to follow, because otherwise you're going to have tick marks all over the place, and it's going to be hard to understand where everything is. I know some books don't like putting those in because it looks confusing, but I don't know. It's hard for me to kind of do that. So, and you might notice that I've left this one at the bottom blank. There is a reason for that. There's almost always something you'll do at that bottom line. Okay, it's kind of a check just to make sure. All right. So here we go, 50. And just go through the numbers. You don't even have to order the numbers. That's the great thing about this. You just go. So 50, where does it fit in? Well, right there. Oh, 50. Cross it off. 40. Where does that fit? Right there. Cross it off. There's your tally, yep. It's easier to do it that way. It's just, well, probably quicker. 41. Right there. 17. 11. Same spot. 7, same spot. We're having a run here. 22, right there. 44. And you just kind of keep going. 28. 51. Now where's 19 go then? It goes 19 to 30, exactly. Yeah, you don't. That's why remember we didn't have to worry about it. So 23, and then yep, up and to the right is normally how you do the slash when you get to those. Okay, 37. I almost forgot where I was. See, that's why you keep crossing them off. 51. Did I mess you up? 54.
When you slashed, did you slash for 19 or for 23?
I did both. Oh, you mean on the thing? Oh, I don't know. That's why somebody I go a little slow. 42. At first, I didn't understand your question, but then I do understand it. I just don't know. So you keep telling it. I've already done that, and so then I'll see if yours matches mine when you're done. All right, again, let's compare. So what I got here for the first class from 7 to 18, I actually got that. All right. For the second class, I got a whole another one of those. For the third class, it kind of made a comeback towards the end there. Okay. Okay, so do you agree that that would be your tally if you did something like that? Okay. Now the frequency over there, and normally frequency will, and I didn't do a very good job of italicizing that, but it'll kind of be like an italicized F. So if you ever see an italicized F like that, that's lowercase. From here on out, think of that as frequency. Okay. So what is the frequency for the class size 7 to 18? It is 6. That's how many times or how often it happened, and that's kind of the words that you were using, so 6. So the frequency for class 19 to 30 is 10, followed by what, 13, followed by what, 8, 5, 6, and 2. Now, the reason that a lot of times if you do a little chart like this or table like this, that there'll almost always be that extra one down at the bottom, is that you obviously want to do a check. You want to make sure this is right before you go on and do more math to this, right? You don't want to have made a mistake here before you go do the more complicated stuff, and then, uh-oh, everything you just did is wrong because you didn't do that. Sigma. Meaning? Okay, now you should know what that answer better be based on how this problem was presented to you. If you read back in the example, you should know what that number should be. Better be 50, right? Because I told you, I gave you, if the minutes in 50, there's some people transpose them in their head. Okay, there's 50 of these samples, okay? And so if you add those up, do you actually get 50 then is basically the question. Okay? And if you don't, then you're really frustrated because then you got to go back and check and see what happened. Okay? But if you add those up, your sigma actually is 50. So that leads me to believe that if I wanted to, I could continue on and do some more statistics with this particular problem. Okay? Again, it would be a statistic because it is a sample. All right? It's not a parameter. It's a statistic. Okay? Now, I don't know how you think about that, but that's probably pretty accurate to mine. Sometimes I stay on a little longer than others. Sometimes it's just go on, check your email, and then you're off, right? So I would agree with those probably. Those are halfway decent, all right? All right. So we got a few more, and then we'll do one more little table thing, and then we'll be done, I think, for today. Midpoint, I think we all know what that means. Middle. Normally for midpoint here, it's going to be of a class size. So basically, it's the sum of the lower and upper limits of the class size divided by 2. I'm pretty sure you don't all have to write that. Okay, basically, it's the average, right? I mean, or the midpoint of that class size. And sometimes, probably the most important part here is sometimes to realize it's called the class mark. Okay, so if you see that word, class mark, or just see mark, know that means the midpoint of that class. Okay? That's normally when you're going to want to take something like that. So yeah, just say kind of the average of the endpoints there. I think that's pretty straightforward. Like back here, it'd be fairly simple. You'd just take the average of 7 and 18, and that's basically going to be your mark or your midpoint. Okay? But I just don't want you to see that word later on and be like, what's that? All right? Relative frequency. Okay? That one's going to be important. We know frequency is how often something happens in that particular interval that we chose, right, in that particular class. Well, relative frequency, the portion or percent of the data that falls in that class. So in that last one, we had 50 pieces of information, right, 50 pieces of data. And we know what, 6 was the first frequency, right, or something like that? What portion of the data is that? Well, that's pretty simple to calculate that. Okay. In fact, that might be, some of you should be able to do that in your head, because if it's 6 over 50, it's 12 over 100, 12%, right? I mean, that's then 0.12, then is how you could write that, or you could write it as 12% if you want. 12 hundredths, yes, is basically the percent or the portion of the data. Okay. Well, if that's relative frequency, cumulative. When you look at your report card, on there you will have your cumulative GPA. Well, what does that mean? Yeah, from everything, right? It's they don't just take from one particular quarter, they just take everything up until that point. And a lot of times your cumulative, I don't think they mess with until semesters. They don't mess with that too much. So basically, it means, so it's the sum of the frequencies for that class and all previous classes. So you just kind of add them up. So it makes sense that the cumulative frequency of the last class is equal to the sample size. Okay, because if I keep adding them all up, shouldn't it be the end? Pretty straightforward, but I want to make sure that you've seen those words. So it's very similar to the chart we just had, except you kind of keep adding the ones before it with it. Okay, and we're going to do something that deals with those right now, just so that you can see it. Yeah. Yeah, that's right.
Cumulative would apply to radio stations. Because like the stations I have watched.
I don't know. I'd have to think about it, of how cumulative would apply to that. If I think about it, I'll probably figure it out. I think I know what you're talking about, too. I think I've heard that. Has anybody else heard that when they talk about it? I have, too. I think they're saying that both stations put together. That's, I think, what they're talking about. So,
When two stations are doing the same thing.
yeah, I think that's what they're talking about, that together they do this. And probably one is maybe out of one place. The tower is a certain place, and then another tower is somewhere else. And so put together, they can get a bigger range than if they are separate. That would be my guess, but I'd have to think about it somewhere. So basically, I'm going to see if I can cheat. I doubt it'll let me, but we're going to try. I'm probably going to get some stuff I don't want, but let's find out. It's always fun to try. You can't do that? Not too bad. I'll take that. So just throw them in there again. Just right click on it. It doesn't work for you? I don't know why. And I think what do we have here? I'm gonna put the lines in again because they help me. Actually, you know what? I can do a better job than that. While you guys are writing, I'll do a better job than that. That's a little thick. We'll use that one. That'll give me something to do while you guys are writing down those numbers. Actually, I should have done a better job than that too, but oh well, we'll deal with it. So you can also put in those frequencies while you're at it, because what, this was 6. Remember, there's that F again. I probably should have seen if you remembered what that stood for. But you can put those frequencies in there again, what, 10, 13, 8, 5, 6, and, well, I should have put another one in there too. 2, I'll go take care of that right now. There you go. All right, and down here, of course, you would want to check just to make sure, because a lot of times you won't do these in separate tables. You'll just do this all at once. Okay, so that's where that sigma would go for this one, right? Because you want to make sure you don't want to go and do these other things if that's wrong, right? And so, again, that sigma is just for that column, and if you did it right, in this case, it would be 50. Okay, and I think we've already checked that, right? And so for these midpoints, basically all you have to do, or again, what's another word for midpoint? What might they put here in that spot? They'll put mark, might be the word that they use. So if you see that in a table, know that's what it means. And it's not the midpoint of like the 6 and the 10, it's the midpoint from the 78 to the 18. What's the mark or midpoint of that range or that class size? And basically if you add those together, you get 25, and so it's 12 and a half, of course. Okay, and so what do we get there? 49, and so that's 24 and a half, right? You get 73, 36 and a half. You think? If our class sizes are equal, which they are, this shouldn't be any big surprise, right? So next one is, what, 97? Right? Are you? That's good. So then what's the next one using your pattern? Yep. Now remember, this only works if they're equal class sizes, which they should be, okay? So that's, again, the mark or relative frequency. We already talked about that one. It's basically this 6. It's 6 out of what? Out of how many total? 6 out of 50. Okay, and we already know that that's, you kind of want to write them as either decimals or percents. Normally it's best seeing we use decimals when we do mathematics. We might as well just leave them as decimals, right? And I already told you that's, well, it's 12 out of 100, so it's 1200s, or 1, 2. Now this one's even easier. It's basically 10 out of 50, right? I'll maybe write a couple of them in there so you can see where it's coming from. Or in other words, it'd be 20 out of 100, right? Or 1, 2. And I think you get the idea at this point, right? I chose some nice. I chose 50 because it works out so nice. So 0.26. Okay, and then you can probably stop writing those in there. So. And what'd you get for the last ones? 0.1, 0.12. Now, basically what they might put here is sigma of f over n. Because f always stands for what again? Frequency. This little lowercase n will always stand for sample size. And isn't that what we just did? Didn't we just take the frequency and divide by sample size? That's what we did, right? And if I add those up, what do I get? Yeah, you better get 1, right? Or 100%, right? Okay, cumulative frequency. Remember, cumulative means, we kind of talked about that in many instances, you know, even that radio station example, it's still the same thing. It's kind of everything together. And so basically the first one's always easy because the frequency there so far is, well, 6. But what they're saying, what you have to do as you do cumulative frequency is figure out what is it for that class and all previous classes. So exactly 16, because it's 10 for this class, the previous class was 6, let's put them together, the cumulative is 16. So you better know right now, if we did it right, you better know that number. It better be, right? A little bit, okay. And so then we know what now? It's easier just to take this number, the 16, and add the 13. Just, don't worry about adding them all up. That's a waste of your time. And so we've got what? 29, 37, 42, 48, 50. In essence, it's another check to say, wait a minute, okay, are we doing this right? What's going on? Right? Because trust me, you don't want to go and do the more complicated stuff if you had done something simple wrong back here. Because then all the data is basically worthless at that point. You got to start over. Okay? So any questions on just general words like, now how do we figure out class size again? Did we just make it up? Oh, let's make it 12. Big minus little divided by however many you're told. Now obviously, does this problem change drastically if I just say 4 intervals or 4 class sizes? Yeah, huge difference, right? Because you're going to, and now remember, the easiest place to make a mistake is just right off the bat. Okay, I know I'm starting at 7. My class size is 12. 7 to 19 is so easy to do. But it's not, because you got, if you think about it, just count them out. You got 7, 8, 9. If you do that, you actually end up with 12 in this case, and if you do to 19, you actually get 13. Okay, so you got to remember when you're subtracting, like 18 minus 7, yeah, that is 11, I agree. But you got to keep 7 in there. You don't subtract it out. Okay, and that's where you can make a mistake. So hopefully you took some kind of note on that.